All right, so this is your review for your test on absolute value and graphing it in set notation, as well as the review for parabolas and graphing those, as well as finding vertexes and additional points to graph it. So for absolute value, the first problem, we just have absolute value of 2x plus 5 equals 11. And whenever it's an equals, we just set 2x plus 5 equal to 11 and 2x plus 5 equal to negative 11. So we set it equal to the number and the negative of that number. And then we solve both equations. We subtract 5 on both sides, we divide by 2, and our x equals 3. We subtract 5 on both sides, divide by 2, and our x equals negative 8. Whenever we have a less than or equals to, or we have a less than, we write a combined statement. Doesn't matter whether it's less than or equal to or less than, it's a combined statement where we take the number to the right of the inequality, we put it in front and a negative in front of it, a less than or equal to 3x plus 1 less than or equal to 10. Now I subtract 1 to all three sides, I get negative 11 less than or equal to 3x less than or equal to 9. Divide 3 on all three sides, we get negative 11 thirds less than or equal to x less than or equal to 3. So that's my algebraic answer. My graphing, I put a point at negative 11 over 3 and 3, and I connect the points, and I put them in set notation as well. Here's the difference between less than or equal to and less than. Less than or equal to, we close the dots, and it's brackets around the numbers. Okay. When it's just less than, we still set it up the same way to solve algebraically, negative 12 less than 5x minus 3 less than 12. We add 3 on both sides, negative 9 less than 5x less than 15, and we divide everything by 5, negative 9 fifths less than x less than 3. But then we graph with an open dot over negative 9 fifths, an open dot over 3, and we connect them like we did with less than or equal to, and then our set notation is negative 9 fifths, 3, but it was parentheses, not brackets. With greater than or equal to or greater than, like we have in 4 and 6, we set up two different problems. 4x plus 6, we flip the inequality and make the number negative. 4x plus 6 is less than or equal to negative 18. And then we keep the problem without the absolute value. 4x plus 6 is greater than or equal to 18. Here we subtract 6, we divide 4, and x is less than or equal to negative 6. Here we subtract 6, divide by 4, and x is greater than or equal to 3. So now we put our closed dot at negative 6 and our closed dot at 3 because it's greater than or equal to, so the dot is closed. And from 3 we go to infinity, from negative 6 we go to negative infinity. Greater than graphs with absolute value always have the arrows pointing in opposite directions. You don't connect the numbers, you go in opposite directions. In set notation, it's always a parentheses around the infinity. But when it's greater than or equal to, we bracket the number. So parentheses, negative infinity, negative 6, bracket, and then bracket 3, infinity, and then parentheses. Remember, parentheses always get infinities always get a parenthesis. If it's greater than or equal to, just like a less than or equal to, the numbers get brackets. When it's just greater than, we set up the two problems, 3x plus 6 less than negative 24, 3x plus 6 greater than 24. We subtract 6 on both sides, we divide by 3, x is less than negative 10. We subtract 6 on both sides, we divide by 3, x is greater than 6. It's now an open dot because it's greater than at negative 10 and 6. The arrows are still going in opposite directions, and the set notation is still all parentheses because it's just a greater than, just a less than. Or, I'm sorry, it's parentheses because it's just a greater than. Okay? The infinities will always get parentheses, but because it's just a greater than, the numbers get parentheses as well. Negative infinity, negative 10, 6, and infinity. Remember, when it's greater than or equal to or less than or equal to, you get closed dots and brackets. When it's greater than or just less than, you get open dots and parentheses, and the infinity always gets a parenthesis. If you have an inequality with a negative, very simple. If this were a less than, it's no solution. An absolute value can never be less than a negative number. If it's a greater than, it's all real numbers. Every absolute value, no matter what you plug in for x, will be greater than a negative number. So if it's a less than, it's no solution. If it's a greater than, it's all real numbers. Now when we get to a parabola, the parabolas where it's in standard form and I cannot factor it, I use my negative b over 2a. So my A here is 1, my B here is 8, and my C here is 6. So negative 8 over 2 times 1 becomes negative 4. And I plug the negative 4 in for x. So negative 4 squared is 16. Negative 8 times 4 is negative 32 plus 6. 16 minus 32 plus 6 is a negative 10. So my vertex is negative 4, negative 10. My C value is always my y-intercept, 0, 6. And since I went right 4, I need to go left 4 for the symmetric point from the vertex. So it's negative 8, 6 is my other point. My line of symmetry is x equals negative 4. And I'm using negative 8, 6, 0, 6, and negative 4, 10 to draw my parabola. And it's always a curved line. It is not a V. Make sure it looks curved. When you have a negative in front of your x squared, your parabola is going to open downward. My A is negative 1, my B is 6, and my C is negative 2. So negative B over 2 times negative 1 is a positive 3. When I plug the 3 in, be aware that negative outside the x gets affected after you square it by PEMDAS, or order of operations. The 3 squared is 9, then we apply the negative 9, or the negative to the 9. So 3 squared is 9, it becomes negative 9. 6 times 3 is 18, minus 2. So negative 9 plus 18 minus 2 gives me 7. So my vertex is 3, 7. My y-intercept is my C term, 0, negative 2. And therefore, my symmetric point, I went left 3 from the vertex. I need to go right 3 from the vertex, so it's 6, negative 2. My line of symmetry is x equals 3. It's always the x value of the vertex. And I'm using 0, negative 2, 6, negative 2, and 3, 7 is my vertex to graph my parabola. If you can factor it and use your x-intercepts. These vertexes are going to be too big, so you're not going to be asked to graph them. You just need to get the x-intercepts in the vertex. So when I factor here, and you should know how to factor, x minus 11, x plus 3, the vertexes, or the x-intercepts, I should say, become 11, 0, and negative 3, 0. To get our vertex, we find the average of the x's. 11 and negative 3 is 8. 8 over 2 is 4. And then I plug the 4 in for x. 4 minus 11 is negative 7. 4 plus 3 is 7. Negative 7 times 7 is negative 49. And that's my y-coordinate, my vertex. So my vertex is 4, negative 49. Finally, if they factor it for you, you can go right to the x-intercepts. 5, 0, and negative 7, 0. We take that average. 5 and negative 7 is negative 2 over 2 is a negative 1. So my x-coordinate of my vertex is negative 1. I plug back in for the x's. Negative 1 minus 5 times negative 1 plus 7, and we have the negative out in front. So it becomes negative 6 times 6, and a positive 36. So my vertex is negative 1, 36.